Okay, let's go over our sample test for the 152 chapter 1 in the college algebra text. Check all the categories that this number belongs. So complex will always be these numbers. Complex includes. This is 7.5 or 7.5 or 7.5 or 15 halves. So it's a ratio of two integers, so it's irrational. And irrationals and near irrationals make up the reals. Reals are part of the complex, but not all of the complex. So it's real. It's not irrational. Reals are split into two parts: the rational ones, the ones that can be written as ratios, and the irrationals that can't be. It's not an integer because it's not a whole number, positive or negative, and it's not a natural because it's not a whole number. The cube root of 125 is 5, and so this is 3 times 5, or 15, which is a natural number, an integer. It's not irrational. Doesn't go on forever non-repeating. This does repeat 15.0000, so that makes it rational. It's a real, and so it's complex. The square root of a negative will produce an I. An I takes it out of the real and out of all of these, but it's still a complex. That's what distinguishes complex from real, if it's got i's, imaginary numbers in it. Okay, 2. Order of operations, parentheses. We do have parentheses, and it says 7 times 6 minus 2. And the order of operations, we have to do the multiplication first. So that's 42. 7 times 6, 42 minus 2 is 40 for the parentheses. And powers, so we've got 16 minus 3 times 40. We have multiplication and subtraction. Multiplication comes first, so we got 16 minus 120, which is negative 104. Here we have parentheses, that comes first, and in there we have 2 to the thirds. We got powers, multiplication, and addition. Powers come first, so this turns into an 8. So this is 7 plus 3 times 8. And 3 times 8 is 24. Multiplication comes before the addition. So 24 plus 7 is 31. So we did everything in the parentheses, so we can write 31. Out here we have a power, and it comes before the multiplication. So we have 3 times 4 squared is 16. 3 times 16 is 48. Minus 31 is 17. Simplify. We have powers on this parenthesis, so we have to do that. And we have, and it says positive exponents, so we have a y to the negative 2. The negative 2 means it should be in the denominator. So we have 5x to the 6th over y to the plus 2. Changes its sign of the power when you go from a numerator to the denominator, from the denominator to the numerator. And you can do that if it's all multiplication. If there's addition, that messes things up. Times 2xy squared, that quantity 3 times. Three times multiplied, that's what the power 3 means. So this y squared will cancel one of these y squareds, and that's all that cancels. So we have 5 times 2, 10, times 2, 20, times 2, 40. X to the 6th times an x times an x times x is x to the 9th. And y squared times y squared is y to the 4th. Here we have, this is a negative number, not a negative exponent, so we can't move it above and change its sign. That stays negative. But we have 2, and this x to the negative 3 should go downstairs, go into the denominator. So we got x to the 3, y to the 4. We have a negative 4, not a negative exponent, a negative number, negative 4. And it's squared, but the negative is not squared, just the 4. If I wanted the negative squared, I'd have parentheses on there. So this is negative 4 times 4. There's 2 4s there, or negative 16. Y to the 3rd, y to the 3rd, and x. Okay, so we have 2 over negative 16. That reduces to 1 over negative 8. We have y to the 4 in the numerator. That's y multiplied. In the denominator, we have y to the 3rd. So 3 of them cancel 3 of them, or the rule for division is subtract the exponent. We have 1y left over in the numerator. 3 from 4 is 1. 1 power. And we have an x left in the denominator. Scientific notation. This says a negative 3 as the exponent, so it means divide by 10 3 times. So if I divide this by 10, it turns into 0.430. Divide by 10 again, 0.0430. And divide by 10 again, 0.00430. And we have to keep the 0 on the end because in scientific notation, they show you all the numbers it was measured to. The 4 was measured correctly, the 3 was, and the 0 was a rounded off of the next place. So that's the correct answer. You can put a 0 in front if you want. Helps see the decimal. Now to turn this into scientific notation, we have 5, and the decimal always goes after the first non-zero digit. So 5. We keep that 0 because that holds a place between the 5 and the 3. Keeps us 5,030,000. There's no 100,000s. These zeros are just shoving the number over, so we don't need to keep those. Times, now to get this number back to this, we'd have to multiply by 10, so it's going to be a positive exponent. And we'd have to multiply by 10 to get the decimal from the end here where it's at to here. We'd have to multiply by 10 once, twice, 3, 4, 5, 6 times. On this one, these zeros are just pushing the 309 over. So the first non-zero digit is 3, and then we write 0.09. That's saying there was no number in here, nothing to measure there, but there was a 9 here. So we got that much times. Now, this is bigger than that, so we're going to have to divide. So our exponent has to be minus. And to divide, we're going to have to move it once to get it to be 0.3, twice to make it 0.03, 3 times to make it 0.003, and 4 times to make it 0.00. So we got to move it 4 times. We got to divide this by 10 4 times to make it look like that. Multiply these and then write in scientific notation. So I'm going to pull out my calculator and deal with just the numbers to start with. And so we have, let's see, put it someplace where the reflection's not so bad. Let's see. I have trouble with the light in here. Okay. 739 times 3.2 is 2364.8, and then there was times 10 to the negative 2, but now to make it scientific notation, I've got to put the decimal after the 2. Well, that makes this number smaller. So to get it back to this size, we're going to have to multiply by some tens. And we'd have to multiply by 10. Let's see. To get this to be that size, we'd have to multiply by 10 once, twice, 3 times. But it's already divided by 10 2 times. So this works together to be times 10 once. So it's 2.3648 times 10 to the 1. Over here, we have, put this up here. Where can I put it? Up here? That'll work. There we go. 4.32 divided by 5, and that's 0.864, and that's supposed to be times 10 to the 5th. It has that in there. The 5 can be divided into this or into that, but we'll leave it in there because this has got that power, and that would have to come before we divide. So we'll divide it into that number. But to be a scientific notation, the decimal has to come there. So it would be 8.64. And to make that look like that number, I'd have to divide by 10 once. So that's this number. But it's times 10 to the 5th. So now we add the exponents and we get 8.64 times 10 to the minus 1 plus 5 is 4. Okay, page 2. So we're looking for cube root. We're looking for groups of 3. We have a 2, an x, and then inside this root, where we're looking for groups of 3, we have a 56, which is 2 times 28, which is 2 times 14, which is 2 times 7, times x, times x, times x, times x, times x. 5x's multiplied. We have a group of 3 2's, which will come out as a 2. So we have 2x to the 2x out there. That's not x to the 3rd, that's the root 3. And we're going to pull out another 2. And we have 3 x's there. That comes out as an x. And we don't have to put absolute value because it's an odd root. And we don't have 3 of anything left. So we have the cube root of 7x squared. And this multiplies to be 4x squared, cube root of 7x squared. And I don't care if you rationalize the denominator. I just want you to simplify. So we have 15 and 3x. And we have the square root of 2 times 3 times x, 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 x. And down here we have square root of a 3 and an x. And these are inside, and so are these, so they can be put together or they can reduce as long as there's not addition. So this 3 can cancel that 3. That x can cancel that x, and that gets rid of that denominator. And 3 goes into 15, making 5. 15 is 3 times 5, and so the 3's cancel, and we get 5. So we now have 5 over x, and we're looking for pairs. And there's a pair of x's, and another pair of x's comes out as an x squared. And what's left in our square root? Well, there's a 2 and nothing else. This x will cancel one of those x's, or using the power rules, you subtract exponents when you're dividing. So 1 from 2 is 1. So we get 5x square root 2. We're doing square roots, so 18 is 2 times 9, which is 3 times 3 times x. The square root of 9, or a pair of 3's, is a 3. So a 3 comes out, and we have 3 times 4, which is 12. And we have left the square root of 2x, plus we have 2 of the square roots of 2x. These are identical. We can undistribute them, and we'd have square root of 2x times 12 plus 2, which is 14 times square root of 2x. Or if you wanted 12 of these things plus 2 more of these things is 14 of those. Square root of 2x. Okay. Go to here. This says cubed root. We're looking for groups of 3. 1/3 power is cube root. 1/2 power is square root. So we have basically the cubed root of 48, which is 2 times 24. 24 is 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. We have x 8 times, and y 3 times. And we're looking for groups of 3. There's 3 2's. There's no more groups of 3. There's 3 x's. That's an x. Another 3 x's. And we have 3 y's. So we've taken out the 3 2's. What's left is a 2 times 3, or 6. We've taken those 3 x's and those 3 x's. There's an x squared left. And we've taken all the y's out. Okay, now let's go to this one. State the degree. Well, that's the highest power. In this one case, it's 4. Leading coefficient, that's how many of the highest power, and it's -3. Powerful near 0 will be the lowest degree, which would be the 2x term. And powerful far from 0 would be the highest one, so that's going to be the -3x to the 4. So over here, the degree is 2. Leading coefficient is 7. That's how many of that x to the 2's there are. Near 0, the lowest degree one would be the most powerful. That's the 5. And far from 0 would be the 7x squared. Simplify the following. So all we have here is addition or subtraction, but we do have parentheses, and there's nothing that can simplify here, but we do have a minus, which means we have to subtract all of these. So I'm going to go and change the minus to a plus and make it, I'm going to subtract this one, and I'm going to subtract, which means I'm adding this one. I'm going to subtract this one and subtract this one. Now I'm going to look for my highest power of x, which looks like x to the thirds. There's -3 of those critters and -1 of those, so that's -4x to the third. Going to look for x squareds. There's 8 of them, plus 5 of them. My x's, there are 5 of them, minus 4 of them, so that's just 1 of them. You can put a 1 or you don't have to. And then the constant, no x's, and there's no constants here, but there's a minus 5 there. And you can write plus a negative 5 or minus 5. Okay, here we have to do some multiplication. So 2x times 5 is 10x. 2 times negative 4, 2x times negative 4x is negative 8x squared. And we got to subtract, so I'm going to change this to plus and change the signs here. We've got to subtract 7x, we've got to subtract an x squared, and we got to subtract, which means we're going to add, and anything to the 0 power except 0 is 1. So now we have plus a negative 7x plus a negative x squared and plus 1. Looks like the highest power is x squared. I got minus 8 of them and minus 1 of them, so I have negative 9x squareds. I have plus 10 x's, that's the next highest power of x, and minus 7, so that's plus 3 total x's, and then a plus 1, or 1x to the 0. Okay, next page. Multiply the two binomials and sketch a model for it. So I'm going to sketch the model first. I'm going to go x. I'm going to call that length x. So there's 2 x's, another x, and I'm going to say that's how long 1 is. So now I got to go 3 x's. 1, 2, 3, and 5. If that's 1, 5 would be 1, 2, 3, 4, 5. And I make a rectangle. And I can draw the lines at each of these places. And I'll just do this one. I won't do the 5 ones here. So this square is x times x, or x squared. And this one is also, and this one. So I get 6x squared. 2x times 3x is 6x squared. So that's in this. And then we have 3x, or well, let's do the 2x times the 5. 2x's times 5. So this is x times 5. So this area is 5x. And x times 5, this is 5x. So 2x times 5 is 10x. That's the outsides. The inside is 1 times 3x. Here's the 1 times x and x and x. So this is 1x, 1x, and 1x, making 3x. And finally, we have this area down here we haven't done yet. 1 times 5, which is 5. 1 times 5 is 5. So there are the 4 products represented in the model. And then if I simplify that product, simplify this, these are like terms, so I get 6x squared plus 13x plus 5. Okay, expand the following. So I need to multiply these, so 3x times 3x is 9x squared. 3x times plus 2 is plus 6x. Minus 2 times 3x is minus 6x. Minus 2 times plus 2 is minus 4. And that's still got to be multiplied times the x minus 1. And these cancel, so I have 9x squared minus 4 times x minus 1. So I got to take the 9x squared times x. I got to take the 9x squared times the minus 1. I got to take negative 4 times x. And negative 4 times negative 1 is plus 4. These are all different powers of x's, so they're no like terms, so that's simplified. Oops, I am so sorry. I had that not where you could see it. So I take 3x times 3x times plus 2, negative 2 times 3x, negative 2 times 2. Those were like terms, so I have this that I have to take times the x minus 1. And I take 9x squared times x, 9x squared times minus 1, negative 4 times x, and negative 4 times 4. I apologize for that. Let's do this one. I can take 3x times the 5x, and that's 15x times x, x squared. 3x times minus 2 is minus 6x. And I have to take that times the x squared plus 2x plus 3. So I got to take the 15x squared times each one of these, and the negative 6x times each one of these. 15x squared times x squared is 15x to the 4. 15x squared times 2x is plus 30x to the 3. 15x squared times 3 is plus 45x squared, because there's only x's here, none there. Now I got to take negative 6x times x squared, negative 6x to the 3rd. Negative 6x times 2x, that's minus 12x squared, x in each of those. And then minus 6x times the 3 is minus 18x. Putting them in order, I have 15x to the 4th, none other. I have 30x to the 3rds minus 6x to the 3rds, that's plus 24x to the 3rds. I have 45x squareds minus 12x squared, so 45 minus 2 is 43, minus 10 is 33. And then I have some x's, only those, minus 18x. Okay, simplify. Well, I can't cancel these or these because these two are tied together with a minus. But if I can do some factoring, I might be able to do something here. 15 is 3 times 5, and that's times an x in the numerator. The denominator, there's a 5 that goes into both of these, so I can undistribute the 5, factor out the 5, and I get x minus 3. Now this is times stuff, and this is times, so these can cancel, but that x can't cancel and that 3 can't cancel because these are tied together. It would have to be x minus 3 up here to cancel this quantity. It has to look exactly the same, and it doesn't. So our answer is 3x over x minus 3. This says divide these. So I'm going to write that as a fraction, and then I got to factor this. Well, since this is a square minus a square, there's that rule that says this is going to have to be 2x times 2x, and 25 is going to be plus 5 and minus 5. Or if you will, you could put 0 matched up with 0, and you look for numbers that make 4 times negative 25 is negative 100. So if you look up your strips, you'll see that minus 10 and plus 10 match up. So you'd have x plus 10 and x minus 10. But you need 4x squared, so you'd have to get you can't get a 4 out of either 10, but you can get a 2 out of this 10 and put a 2 there, and that would make that a 5, and take a 2 out of this, and that make it 5, and put a 2 there, and now we're to that. So that's how to do it with the strips. In the denominator, we have 8x to the third, 40x squared, and 5x. And I believe if I were to write this out, 8 is 2 times 2 times 2 times x, x, x. 40 is 2 times 20, which is 2 times 10, which is 2 times 5. X and x, and minus or plus 50, which is 2 times 25, which is 5 times 5. X. And I see 1 2 here. There are 3 2's there, 3 2's there. So what's in all of them is a 2. And I see 3 x's, 2 x's, 1 x. So there's an x in all of them. And so I get what's left, which should be 4x squared. And if I take a 2 and an x out of here, I get 4 times 5, 20 x. And if I'm taking a 2 and an x out of here, I've got plus 25. And if I line 20 on the strips, which it's going to be hard for you because they don't line up, but they got to add to be 20 and multiply to be 100. Add to be 20. So like 5 times 15, add to be 20. 6 times 14, 7 times 13, 8 times 12. They've got to be 100. That's 96. This is smaller, so 9 times 11 is 99, and 10 times 10, add to be 20, and multiply to be 100. So it would have been 10 and 10. So we got we have x plus 10 and x plus 10. But we have to have 4, so we're going to take a 2 out of here again and put it here and leave a 5. And we're going to take a 2 out of here, leave a 5, and put a 2 there. So we get 2x plus 5 and 2x plus 5. And so the 2x plus 5 will cancel, and nothing else will, because this 2x can't cancel that 2x because it's got a add or subtract. So we get 2x minus 5 over 2x times 2x plus 5. Okay, we got subtraction here, but we can simplify this. So we get 5x, and this says subtract these, so that's plus a negative 3x and a negative 2. The subtract changes the signs of these. So we get 5x minus 3x, which is 2x plus a negative 2, or subtract 2, over, if I put these in order, I have x squared minus 7x minus 8. And looks like I can pull a 2 out of both of these. I can undistribute a 2, so I got 2 times x minus 1, because 2 times x makes 2x, and 2 times the minus 1 is minus 2. And if I line up 0 and negative 7 and look for what multiplies to be 8, it would be a minus 8 and a plus 1. Minus 8 and a plus 1 on my strips will add to be negative 7 and multiply to be minus 8. So this factors to x minus 8 and x plus 1, and nothing cancels. So I can't simplify any more than I can leave it like this or leave it like that. And then I'm gonna, I need to add some problems for the last page that I did. I don't have that right here. Okay, so that's the first 3 pages of the sample test.